Alright, so here are our warm-ups. You guys now know another way to do these besides setting it equal to a variable and writing it in exponential form. Do you remember how? We did on Thursday. I said this is one of the most important things to learn about logs. What'd you say? No. It's called the change of base formula. It gets the 2 out of the base and makes them both something you can type in the calculator. Remember that? No. You can put this 4 in front of the log. That's when it can go in front. We are, but he suggested a method that was not applicable to the first problem, but it was to the second. So, okay, back to the first one. Yes? Nope. If it was multiplication in the argument, you can change it to 2 different logs with a plus sign. Yes? I have no idea what you're talking about. We're going to go back to the first one. Why don't you look back in your notes? This is the last thing we took in our notes, so you probably just have to flip back a page. It's called the change of base formula. Or we can do it the old way by setting it equal to a variable. Somebody give me a method they want to use. You can use either method you want. You have it backwards, but that's the closest answer I've got so far. Yes, it's log 64 over log 2. Both of these are log base 10, so you can do it in the calculator. This is the change of base formula. This makes lots and lots of problems easier because now you can just type it in the calculator. So do that. Make sure that you close the parentheses around the 64. It'll open a set. You got to close the set for it to work. Wow, that hour of sleep really is getting to you guys. What are you getting there? 6. Great. All right, so how would I rewrite the second one? We move the 4 out front. It's a valid move. That's one of the log properties we learned. If it's in the exponent, you can move it out front. Now, can I rewrite that as some sort of change of base formula? We just did it on the first one. Try to notice the pattern. Deal with the 4 at the end. I'll put the 4 out front. Log 9. Good. Great. So you can type that in the calculator. You could do the times 4 at the beginning. You could do the times 4 after you figure out the answer. Anyone got it for me? 8. Great. Any questions? All right, today we are starting section 8.6. It's all about solving equations. Some of them will be exponential equations. Some of them will be logarithmic equations. My goal is to get through all of these examples today, and then tomorrow will just be a work day. So today might be notes the whole time. It depends on how quickly we can get through these, but it is a lot of notes. All right, here are our first 2 examples. So, the hard thing about today's lesson is a lot of the problems are very different. So we're going to look at a few different types. These are both where the base is already the same and you have something in the exponents. So if the bases are already the same, and I'm telling you that these two expressions are equal, what has to be true about the exponents? They would also be equal. So I am just going to set the exponents equal now. So again, if the bases are already the same, and you know that they're equal, that means the exponents have to be equal. So we're just going to forget about the bases, and we're going to solve for the exponents. Alright, that's just a basic equation. You get your x's together, you subtract x from both sides. You'd have 2x equals 8. You divide both sides by 2, and you get x equals 4. Any questions on the first one?
So do we plug the 4 in?
You can plug the 4 in to check if you want.
But the x equals 4 is the answer?
Yep, but x equals 4 is the answer. If you plug it in, you'll get 5 to the 12th on the left and 5 to the 12th on the right, so you know that it's true. Alright, so using this strategy, what's the next line going to look like in number 2? Yep. 2x plus 3 equals 4x minus 1. Again, once the bases are equal, they came equal on this one. You can just set the exponents equal. To solve that, I'd subtract 2x from both sides. And then I'd add 1 to each side. So we're kind of skipping some steps here. I'm assuming you guys can solve these regular old equations. Divide both sides by 2, and you get that x equals 2. If you need me to fill in the steps in the middle, just let me know. I'm just assuming you guys can handle these. Questions on these? All right. Here's the next one. Now, the whole reason we could set the exponents equal in the last one is because the bases were already equal. So we have to try to see if there's a way to make 25 and 125 equal to each other. You said take the square root of 125? So we could rewrite it as a base. What's the whole point of taking the square root? To turn it into a... You're on the right track. What is the square root of 25? 5. So you could think of 25 as 5 squared, right? So the base is now a 5. What could you do to the 125? Could you turn a 125 into something with a base of 5? 5 to the third. Good. So that's our strategy here. We're going to rewrite the 25 as 5 squared. We're going to rewrite the 125 as 5 to the third. Now, we have an exponent to an exponent. What do you do with exponents to exponents? You multiply them. So the bases are both 5. We have 2 times this exponent. We have 3 times this exponent. So I multiply the exponents. You can see that we just distributed the 2 here. 2 times 2x is 4x. 2 times a half is 1. And then 3 times x. So now you can see both base 5. The biggest mistake I see here is people don't distribute this 2. They would just make this a 4x plus a half. So be careful. If you're multiplying it by the exponent, multiply it by the whole exponent. Now we can set those exponents equal. And you can solve from there. If you subtract the 4x from both sides, you get 1 equals negative x, which means that x equals negative 1. Questions? Alright, here's number 4. Same basic strategy. We're going to try to write them as the same base. There's actually 2 ways you could do this one.
4 squared.
Yes, that will work. So 4 squared, and then we won't have to do anything to the right side. It already has a base of 4. Once the bases are equal, you can set the exponents equal and solve. So that one was pretty simple. Another way to do this, you can change them both to 2's. It's a little extra work, but you should end up with the same answer. Questions? All right, here's 5 and 6. All right, now this is a totally different type of problem. I told you we're going to look at a few different strategies for solving equations involving exponents. So if you can get the basis to be the same, that's the easiest way to do it. That's what we've been doing so far. Is there any way to make 5 and 8 have the same base? They're not both like 2 to the third or like 2 squared or something. You can't make them both have the same base. So the strategy here is to take the log of both sides. Once you take the log of both sides, what can I do with this x in the exponent? Put it in the front. That's the whole point. The way you get x's out of the exponents is to use logs. Because once it's a log, you can move it out front, and now it's not an exponent anymore. Solving for variables and exponents is very tricky. It's not something you can just magically do. You can't like square both sides or take the square root of both sides. You have to be a little more creative, so that's where logs come in. So how would we get this x by itself now? Now that it's out of the exponent, being multiplied, how would I get rid of the log 5? Divide it. So I need to divide both sides by log 5. This is something you can do in the calculator. They're common logs. These are log base 10, so you can do log 8 divided by log 5. Make sure you close the parentheses after the 8 or it won't quite get it for you. And you should be getting 1.292. Questions on 5? All right, 6 is a little different. Anytime you see the e, what should you be thinking of? Not log base 10, but log base. I'm pointing to it. Log base e, what's log base e look like? ln, it's the natural log. So this time the strategy is to take the natural log of both sides. Now that property still holds true that now we can take the x out of the exponent. But what happened to this? What is the ln x or ln e? What happened there? Type it in your calculator. Type ln e. What does it tell you? You might have to take e to tell it it's e to the first, because it automatically wants an exponent with the e. But the natural log of e is 1. So you move the negative x out front, and then ln of e is a 1. So that's how we got rid of that. Now, natural log of 5. Type it into your calculator. It'll give you a decimal approximation for it. And then we just divided both sides by a -1. So there are a few steps missing in here. If you can't quite follow it, let me know and I can write the middle steps. The key here is that the natural log of e is 1. What are your questions? I think it might be helpful in these notes to write these little hints. I don't know if you guys ever see these. It kind of gives you the strategy on top. So the strategy we're looking at now is taking the log of both sides. And again, that's a trick for getting x out of the exponent when you cannot get the basis to be the same. Questions on these two? All right, we're looking at the same strategy. You can see on top now we're still taking the log of each side. The trick here is to get the term that has the x in the exponent by itself before you do anything with the logs. We don't want log of 2 to the x plus 1. We just want 2 to the x. So first you're going to subtract 1 from both sides. Then you'll take the log of both sides. The whole point was to get that to get that x out of the exponent. And then what would my final step be? Divide by log 2. So you're going to do log 4 divided by log 2 in your calculator. It's going to give you some sort of decimal. Hopefully it's close. Oh, actually, no, it's a whole number. 2. A lot of times these are decimals, but sometimes they're nice and neat. Which makes sense because we all know that 2 squared is 4. 4 plus 1 is 5. Yeah, should see more. Questions on that one? Alright, same strategy in number 8. We cannot take the log of both sides until the term with the x and the exponent's all by itself. So what would the first thing I need to do in 8 be? Add 6. You want to just add 6 to both sides. Pretty simple. Now you can see the only thing on the left is the 10 to the 2x. That's when you want to take the log. Now, this is kind of like that example on the last slide with e. This is the common log of 10. It's kind of like saying 10 to the what equals 10? 1. This whole thing right here is a 1. So we can move the 2x out front, multiply it by 1, it's still just 2x. And then the rest is just calculator work. You're going to divide both sides by 2. You're going to type it in. You're going to get a decimal. 1.091. You can notice in most of these they're rounding to 3 decimal places. Unless the directions say otherwise, I would stick with that. 3 decimal places seems to be kind of the common length on these. All right, questions on 7 and 8. All right, you can see up top we're going to stick with this strategy a little longer, taking the log of each side. How should I start number 9? Yeah, you want to try to get that e to the x by itself. So we're going to subtract 9 from both sides. We're also going to divide both sides by -4. If you can take care of the numbers beforehand, do it. Now, anytime I see an e, I shouldn't be using log base 10. I should be using, ln, the natural log. Now, it skipped a couple steps. I'm going to write them out in between. When you take ln of e, what do you get? 1. So now you have 1 times x when you move the x out front. And then in your calculator, type in ln 1.
0.
That's how they get x equals 0. Remember, ln of 1 is asking you, basically, the base is e. E to the what would give you 1. Well, anything to the 0 gives you 1. So that's how you get 0 here. So a couple steps missing.
I'm confused.
All right. Do you understand from here to here?
Mm-hmm.
Do you understand from here to here? That divide both sides by -4? All right, so we are at e to the x equals 1. Well, there's 2 ways to do this. You can just reason through it from here. How do you get any exponent equal to 1? Anything to the blank equals 1.
0.
Anything to the 0 power equals 1. So that's kind of how they went from here to here. But if that's not something that you have just memorized, you would take the natural log of both sides. All right, we can get the x out of the exponent by moving it out front. So you have x times the natural log of e. What is the natural log of e? 1. And if you don't know that, type it in your calculator. You'll just have to tell it that it's e to the first. So the natural log of e is 1. Oh, my thing froze up on me. And then if you type in natural log of 1 in your calculator, it'll give you 0. So this right here becomes a 1. X times 1 is 1. And then you can type this in the calculator and it gives you 0. Does that help? All right. Any other questions on 9? We'll jump to 10. All that writing's going to go away as soon as the animation kicks back in. So there you go. So the first step in number 10 was to multiply both sides by 2. Multiplying both sides by 2 got rid of this 1/2. So again, you want to get it as simplified as you can before you take the natural log or the log of both sides. So getting rid of that 1/2 is just going to make things a little easier. What should I do to both sides? Yep, ln. What is this whole side going to simplify to? We've seen it a few times by now. Negative 2x. ln of e becomes a 1. This comes down out of the exponent out front, so it's negative 2x. And then from here, it's a calculator problem. Type in natural log 12 and divide it by negative 2. And you should be coming up with x equals negative 1.242. Now, I've been sort of showing you the answers and hoping that you're following along with the calculator. The key is knowing how to enter this stuff in the calculator. So if you're just taking my word for it, you might not quite be getting it on your homework. So make sure you actually know how to type these things in. That's going to be very important. Questions? All right, this is kind of like the first idea we looked at. Remember, if the bases were the same and they were equal, the exponents have to be the same. That's the same thing that's happening here, right? They're both logs. They're both common logs, base 10. And they're equal to each other. So what you're taking the log of needs to be what? Equal to each other. So this is essentially just x plus 3 equals 3x plus 1. Very similar to the first type. If these two expressions are equal, you're taking the log of both of them. The expressions that you're taking the log of must also be equal. All right, solve these so you can subtract x from each side. That leaves you with 3 equals 2x plus 1. Subtract 1 from each side. Divide by 2. You get x equals 1. So again, this is a new strategy. I told you several strategies we're going to look at today. Here's just another one. Add to the list. Questions? Here's another one. The only difference now, instead of log base 10, these are log base 2. It's the same basic principle. So looking at this equation, what must be equal for this to be true? Yep. The arguments of the logs. Good. X minus 1 and 2x plus 1. All right, get your x's together. Get everything else away from those x's. And you should be getting x equals negative 2. Again, if you need to see those middle steps, just let me know. But this is assuming you know how to solve equations. Questions? Same strategy. What am I going to do?
4 minus x equals 4x minus 1.
Perfect. And then from here, you're just solving an equation to get those x's together. Get rid of your adding and subtracting. Adding 11, and then divide by 5. Again, if you need those middle steps, just let me know. The only really new part is just this first step, the red line. Once you get to there, you should be good. And just like any solving equation, the way to check that you're right is to plug 3 back in. This would give you ln 1 and ln 12 minus 11, 1, so you'd be good. You don't even have to type it in the calculator. Questions? Sure. I don't remember off the top of my head. I wrote this last week. We good?
Yeah.
All right, here's number 14. All right, let's see if you guys can come up with a strategy here. This is not like any one that we've looked at so far. There's not logs on both sides. There's no variable in the exponents. Anyone think they know a trick here? Maybe something that'll make this a little more friendly to work with? What's one of the first things we learned about logs? How to rewrite them? Using exponents? Anyone remember this? The little curly trick. So where do I start?
8.
The 8. This is like 8 to the 2/3 equals x minus 5. All you're doing is taking that basic exponential to log form that we learned the first day we started talking about logs. I showed you the curly trick. So you start down with the 8 to the 2/3 equals x plus 5. Now, you can do 8 to the 2/3 in your calculator. Or you can think of it using radicals, right? That's the cubed root of 8 squared. Well, 8 squared is 64, and the cubed root of 64 is 4. So it's kind of bringing in some old stuff. But again, if you know how to type it in your calculator, just type it in 8 and then the caret button and then 2/3. Add 5 to both sides, you get 9. Now you might be thinking, well, I don't know how to check this in the calculator. You could plug 9 in right here, you get 4, right? You could use that change of base formula to check this. So you do log 4 divided by log 8, and you should get 2/3. So if you're interested in checking it, don't forget what we learned last week about changing bases. What are your questions on 14? All right, so this looks very similar to the last problem, but what's going to mess us up here? The 3. What's the easiest way to handle the 3? Divide both sides by 3. If something's bugging you, get rid of it to begin with. That 3 is going to bother me. I don't really know how to work that into exponential form, so I'm just going to get rid of it. Divide both sides by 3 and it's gone. What's my next line going to look like? This next line is the key.
5 square root of 2.
I think I know what you're trying to say. You're not quite saying it right. Yeah, just 5 squared.
Oh yeah, that's all right.
Yep. So 5 squared equals x plus 2, or x plus 2 equals 5 squared. It's the same thing. We know that 5 squared is 25. 25 minus 2 is 23. You guys getting the hang of this a little? Questions? Here's 16. Looks like we have the same problem starting this one. Something's bothering me. Yeah, it's that 4. Get rid of it. Doesn't work out as neatly as the last one. What's our base here?
Is it 1?
E, right? That's a natural log. So our base here is E, you just can't see it. So this is e to the 5/4 equals 2x, or you can write it this way, so your x is in the front, 2x equals e to the 5/4. E to the 5/4 is something you can do in the calculator. Be careful with your parentheses. When you hit e to the x, it opens a set of parentheses. Do not close it until you've entered the 4 as well. That's what we were having trouble with in the back. So you should get something along the lines of 3.49, and then you divide it by 2, you get 1.74. Now, we've been rounding to 3 decimal places, so if you want to stick with 3 decimal places, that's fine. This example came from the book. They went with 2. Just usually follow your directions or go with 3. Anyone need a little more explanation on how to enter that in the calculator? It's kind of a tricky step. All right, here is your homework. You can see a special note up there. Tomorrow is a work day if you are in class. If you are testing, you need to finish this assignment on your own. So, like I said several times, there are different strategies. I think we learned 4 or 5 strategies to solve these. So as you start doing them independently, you might need a reminder of how to get going. That's what we're going to do in class tomorrow as you guys are working on your homework. So you can go ahead and start it now, work on it tonight. Tomorrow will be time to finish it and time to ask questions if you're here. If you're testing, you need to just work on it on your own. Any questions?